So Hannes Weigt is next. Got his PhD from Dresden. He is presently the head of the Research Center for Sustainable Energy and Water. Is that right?
Yep.
University of Basel. He's been in the faculty there since 2011. Previously, you were a Jean Monnet Monnet Fellow at European University, and let's see, some Institute of Regulation, right?
Yeah, but that's just the 1 year PhD fellowship. You just end up at one of the offices there, and then you do 1 year whatever you want to do. So is this thing on?
In a nice place. No, I hear it. I think it's on.
Okay, then it's fine.
Okay, and Bert Vellen will be your nemesis, so
yep.
Take your half hour and...
Okay, so welcome from my side again. For the closing of the day, we are more going into, I want to have a lot of criticism on the idea we have, because this is work in early progress. We're not even close to having a good draft, just ask Bert. And it's a little bit of market design idea behind. So we talked a lot about what's the problems we face, and just summing up, I think most of those buzzwords already appeared during the day. So we had this problem with a lot of renewables. We have this investment issue because it's all fixed cost structures, no variable costs anymore. We talked a lot about storage that needs to accompany renewables. We're going to go more with the backup option here. What we didn't talk so much about yet is the role of consumers in that game. So we talked about capacity market designs, about bidding of suppliers. We want to also focus on the role of the consumer side in there, because in the long run they're likely not going to be pure consumers. And naturally the question of the market design should address all those issues, short and long run, investments, operation, all that. And the setting we use here is going from the old world we are used to into that new reality where those 3 bullet points all matter. And what does change? What does impact that reality? So let's shortly start with how's the old world based. And here we're talking more about end user perspective. So not the large guys going on the markets, and the end users typically had a quantity-based average tariff. At least that's what we had in Germany, that's what we have in Switzerland. I assume it's the same in the UK. You just get some average price over the year as a tariff structure, grid tariffs on top, taxes on top, and the like. You implicitly have a high reliability, but you never chosen that one. At least that's in Germany and Switzerland. I'm connected to the grid. I never have chosen to have a lower reliability than that, and I cannot choose a higher reliability without much trouble, at least not as a household. And from a system perspective, well, we had a large set of larger suppliers, but they're all more or less kind of similarish in their structure. Now, what will change in the future? If we assume that we're going to have smart grids and smart meters, reliability will be able to become a private good. They can shut me off if they want without having any impact on somebody else. That's not possible today because they would need to shut down the whole street. So that will change. Generators will likely become way more diverse because you're going to have small scale investors, large scale investors, different types of risk preference in their generation and storage investments. So they are likely a little bit more harder to assess from a pure risk neutral perspective, so we should move on there as well. And then there's this general problem, okay, how do we deal with the fact when the sun is not shining and the wind is not blowing? Do we have backup? Do we have storage? Am I the one building that backup and because I'm getting more flexible? And if that's not the case, so if I somehow don't react on those conditions, I'm gonna need this backup capacity somewhere else. So that's the structure we take as a background, and we come up with, okay, what can we do to come up with a nice market result? Well, first one, go with real-time pricing. Give every consumer that's now privately with their reliability constraint just a nice real-time price, and then I see, yeah, today the sun is shining, prices are low, tomorrow maybe not, prices are high, I'm gonna react. Solves a lot of problems. If we assume an elastic demand, basically we're all out of work because then all the problems we're discussing about are simply gone. So that's boring. So we need something else. And at least we think that in reality, full real-time pricing for all consumers is likely not going to happen. Because either we are not running all the way with our apps and see, oh yeah, now the price in Sweden is, I don't know, 150 euros per megawatt hour, so please turn off my fridge now, and I'm playing around with that. Or I'm gonna have the automation in there so that my fridge turns off automatically. technically speaking, all that is possible, but likely we may not see that in a large scale. So that's our basic assumptions. If real-time pricing would be possible, let's just stop there. If real-time pricing is not possible, the big question is, okay, what can we achieve as a kind of second best? Without the full flexibility on the consumer side, but still accounting for the fact that we likely have a willingness to pay for reliability, that we still have some kind of flexibility in our behavior. And that needs to be somehow translated on the investment side so that the investment guys get that signal to basically get enough money for their investments that provides that reliability. And we are not there yet. We would also have to like the most efficient mix, but as you will see, we work with a pretty simple model so far. What do we think could do that? And that's more or less the only slide you need to remember, and then criticize later on if you think that's a good idea or not. Everything that follows is just trying to explain a little bit more how that world looks. We think that, like in the old world, utilities should be at the center stage. So they are the ones talking with us, figuring out what we would like to have, and they are the ones buying from whoever is generating electricity. Now, what is different compared to the old world? The difference is now they're not only selling electricity in terms of a quantity, they also ask more or less what's the quality of electricity we would like to have. How we define that, we will see later on, but there's this reliability element in there. And once they figured out, okay, look, those guys are willing to pay for that amount of reliability, they go on the generation side and say, okay, you generator, can you provide that level of reliability I just sold to my consumer? And that's basically where we are quite open in the market design that's going with that. So it doesn't need to be an hourly spot market for all generators. It could easily be that the renewable guys just get a fixed payment because, well, you know how a PV production profile is looking. You know what the uncertainty is behind. So if that part of this investment fits into the reliability mix you want to have, you can actually agree beforehand on what kind of price you want to get, without any capacity market at all. So there's no capacity market in here. It's basically translating our willingness to pay into some kind of mechanism that generators can benefit from that by just having a contract with the utility that pays for this. That's a little bit the idea. And for now, we just differentiate between renewables and dispatchable technologies. We could think about extending that to storage, but that's like the main difference we have. That's it. That's our design idea. It's not that great, I would say, in terms of explicitity here, but let's give it a little bit more detail. And as I said, we're pretty early in that old stage, so there's not that many results, but at least some basic idea how we want to solve it. That's looking like this. We have consumers. They have some utility function in there. Depending on the consumption you actually have, so that's the quantity. Depending on the reliability they have, that's the quality. And then you have some income constraint just telling you, okay, your income minus whatever you need to pay for electricity is reducing your overall utility, and then you have the utility just from consuming electricity in there. So a pretty generic household in there. No specification about demand structures or anything. The utility sits right in the middle, buying energy from generators and selling those energy at contracts with those two prices to consumers. And the thing they ensure is that certain level of reliability. We'll get back to that in just a second. And then we have the generators that basically can invest into controllable, dispatchable, conventional generation or whatever, and the renewable generators with pretty low marginal cost. You have fixed investment cost, variable cost, and you have an availability. So what's the timing and relation structure we have? We assume that like today and likely also in the future, we're going to get some kind of average tariff. And on that average tariff, we are flexible. So if I would get double the electricity price as a tariff, I likely would make some changes in my home, consuming less electricity. But since I'm not getting a timed signal, I don't know that at 7 in the evening I need to reduce my demand, or when the sun is shining I need to increase my demand. This is all translating into a rather fixed time-independent structure. So the idea is, okay, we have some flexibility here, just a linear representation. In the model, we don't specify how that relation is at all. Just assume you have a normal demand function. You give that guy a tariff, you're going to get some consumption. And then This is basically just saying that this consumption translates into a specific demand at a specific point in time. For our little model, we just have one point in time. That one point in time is differentiated whether there's renewable available or not. So we have two states of that one point in time. Either the sun is shining or the sun is not shining. That's the only difference we have. You could extend that having off-peak and on-peak structures, things like that, but we keep it simple. So there's actually just one period where you get an average tariff. That one period has two probabilities regarding the availability of renewables. That's it. That's the whole setting. Now going back to this reliability thing. What is the reliability this utility is ensuring me? Well, I want to have some consumption. That's this one. And I'm going to get some energy in that state, and I'm going to get some energy delivered from my utility in the other state, D1 and D2, and this is just the probability in there. We make it simple and say, okay, look, in that state, when the sun is shining, I will have enough capacity in there because I have the renewables and the conventionals. But likely in that state, we will see. That may depend on whatever I'm going to do, whether I still have enough capacity. That is this backup question. How much conventional do I build? So we are more interested in what's happening here. And so this is just a ratio. It's just telling you that maybe on 0.99 or 0.95. That's about it. So that's the basic design we have. Now, what we do with that? Let's try to replicate the old world. A world where we had basically imposed reliability. Reliability in the sense of energy being available, not tree falling on a line. That's always a security issue that needs to be covered anyway. So how was that in the old world? Well, it was an integrated utility most of the time. So that integrated utility was selling electricity to us, having a generation cost, and now for the short notation. So the MES, those are variable costs for the dispatchable and the renewable generation. The Qs, this is the quantity of the controllable conventional generation, and the Q2 is the renewable. Whenever you see that upper bar, it means it's at its capacity maximum. Now, alpha, that's the state when the sun is shining, and so naturally our renewable will be at capacity maximum because that's how we defined it. It's either there or not there, 0, 1. You can refine that with a more fine-grained production portfolio if you like later on. And you could assume, okay, this one is 0. Sun basically has no marginal cost, but you will likely also still need a bit of conventional technology. So that was this section here. And you're going to have variable cost for that. In the state when the sun is not shining, your conventional capacity will be at its capacity maximum by definition. In that simple setting, building more capacity does not pay off. Building less capacity in that world is not allowed because we say that our consumption in both states need to be equal and basically cover whatever my consumer want to have based on that average tariff. And those are just the investment, the fixed cost components depending on the state. We played around with that. I'm not showing a lot of mathematics in there, but we found some nice effects on the side in there. So one effect, for example, is that there is a nice feedback effect from pushing in renewables to the backup. And that backup comes over the consumption structure and could be in any direction. Let's just shortly visualize that. Assume a world without any renewables. Then this game is boring as hell. I'm installing a tariff, I get my consumption, I only have one state of the world. There's no renewable. So whatever the cost function for my conventional technology will be, that defines the cost level they need, and that's defining my tariff. That was the old world. Now in the new world, I have those two stadiums. Basically, sun is shining, sun is not shining. I know that when the sun is shining, well, that's going to depress market prices in that regard, the merit order effect. When the sun is not shining, it's just the conventionals over there. Now, whatever tariff I defined, I'm going to have the same amount of demand in those two states for the consumers. So the lightly blue line is just indicating, hey, actually we are flexible, but we don't get a signal in that time frame to activate that flexibility. Now what will happen? With the merit order effect, the price in that time I have to pay on the market, for example, will be lower. Everything else fixed, that means also my average price should be lower, because in that time frame I'm not paying the same price as before, so I should actually give the consumer a lower tariff, which means a higher demand. Now if I have a higher demand, come on. This fixed time independent demand here moves out. That's just a normal effect. So you somehow distribute your average demand structures over your time frames, and that if you consume more in the year, you should need to consume more at specific times. And this is interesting here. Because if I would, for whatever reason, push in renewables from a state budget, so basically saying I have subsidies for renewables and it's coming out of the state budget, so no feedback effect on my electricity price in terms of higher levies or so, I will just end up with lower prices here, a lower average tariff there, and thereby having more demand in those situations when the sun is not shining, and actually needing more backup capacity. That's just a side effect in a sense. You can play around. If you have specific cost functions because you still need to repay that, so the next element would be, I need to repay that, I'm going to have some feedback effect on the tariff again, and that's going to be ambitious, depending on my cost assumptions, my demand elasticity assumptions, and the like. If I impose feed-in tariffs that I have to refinance via electricity consumption, likely you're not going to end up in that state. But just for example, in Germany, a lot of the large-scale consumers are exempted from the levies. So they benefit from those low prices, but they don't need to basically pay that. So if they would have some kind of average tariff structure by their supplier, you may end up with needing more backup because they push out their demand. But that depends on what tariff structure they have. That's just a side effect we see in some of the dynamics we have in there. Another effect, and that's going back to this integrated utility, is actually if you would just give them optimal investments, so no subsidies, no investment, market premium schemes, whatever, how would they actually invest in the two technologies? Well, let's start with this. This is kind of more obvious, I would say. You only get money for renewable energy in the state when the sun is shining. How much do you get? Well, assume that the variable costs of renewables are zero, you can kick that out. Then it's basically just telling you you're saving variable costs of conventionals. So as an integrated company, the only trade-off you have if you internally optimize your renewable investments without some subsidy or some other effects, you go with your marginal investment cost for renewables and substitute them to the variable cost of your conventional generation, which means that your investment and the price you set for your conventional is completely independent of what you do on the renewable side, because it's just a substitution effect on fuel costs. That can naturally change if this investment, for example, is imposed externally and the like. So we still need to do a lot of work to analyze that case. Now the next one, what would happen if we price reliability? That was the old world. Externally imposed 100% reliability. Now allow this utility to provide a different set of reliability, basically saying I'm giving you a price for the quantity, giving you a price for reliability, buying on the market my demand 1, that's the one when the sun is shining, buying on the market my demand 2, that's the demand I satisfy when the sun is not shining, and the reliability is basically defined as well, D1 equals consumption, so whenever the sun is shining there is no reliability problem, but D2 does not need to be equal to D1, so I can actually satisfy a lower demand, which means rolling blackouts in that regard. So just shortly jumping in, the logic would be, okay, in this state of the world, I would have sufficient capacity, but in this one, I'm actually not able to satisfy this D1 level because there is too little capacity in the system. Why is there too little? It doesn't refinance. Actually, I want to have a price signal for that information. How much value do I put on this investment, guys? And those investment guys, they just go on the market. So the conventional generators, they earn money in both states. But the investment in this block is naturally defined when the sun is not shining. This guy only makes money in that state of the world, so it depends on the price they get in that market. And this is translated here. So here you have the marginal investment cost for the conventional generator, and that will depend purely on the price in the second period. And the marginal cost for the renewable guy, he will figure out, okay, how much money do I get in the sunny period, and then decide about investment. So going back into that logic, it's basically distinguishing the different actors. What we cannot tell you yet, at least I tried yesterday night to get that out and running, but somehow I'm just circling that in this little setup I end up with D2 being always equal to D1, so I'm not quite sure if there's another problem in my mind or in the model or in the basic setup. But the idea would basically go into that way. You are able to reduce the demand in the period when the sun is not shining, and the consumers will give you a price signal for that value. And that you can translate more or less to the investors and basically allowing them to provide that reliability. As I said, as you see, it's pretty early. We are not really gone through all the details yet, not close to that. Where we actually want to go with that, if this setup makes sense in the first place? Well, where do we want to go is stepwise. So you could imagine that in this world here, where everybody has to agree on the same level of reliability. So this is just telling you this is the whole demand the consumers have. This is the one that you don't cover in that period. So with a uniform random distribution, you would just turn off specific consumers in that time. Well, that may be not what consumers want. So maybe you would like to have a two-part structure. You want to have a base tariff, which is guaranteed, so 100% reliability in all states of the world. And you may want to have a more flexible part. So that's going, for example, if you have a separation with your current structures in the home, everything that is your normal operational structure will be in here, and everything that's more flexible, like the fridge, like a heat pump or so, could go in there and be turned off because actually the cost for that is not that high for you. So again, if your fridge is now turned off for 2 hours, you wouldn't mind. So that should be somehow be connected to that system. But if you go home and want to turn on the light, you want to get that light on because that's why you turn it on. So that should be in that side of the game. And naturally, you need an incentive constraint so that the consumers are not somehow able to move this one over there and just say, okay, look, I put my fridge in that socket and then I get it for a cheaper price or so. But that's one option to extend a little bit more this 0-1 structure we have with the reliability here. The other one is going more on the generation side and say, okay, having an on-off structure, sun is shining, sun is not shining, is kind of not really nice in the long run. We need a little bit more differentiation. And one differentiation is having more renewables in there, wind and solar. But especially if you think about households, it's more solar. Nobody of us is going to install a wind turbine on our roof. But we are still open to figure out what kind of PV, for example, we want to put on our roof. And this kind of PV can be, for example, south-facing or east-west facing, depending naturally on what rooftop you have, but also depending on what reliability maybe somebody is providing you. So if you figure out that the problem occurs normally in the evening and morning hours, you may have an incentive with that structure to go for an east-west facing solar panel because that shifts generation into those hours when the south-facing are not generating. So just really simple, the south-facing would have a period noontime producing 1 and the other 0. East-west, you could just differentiate a little bit. But that's a little bit the idea. The conjecture we have here, what is the utility doing? The utility is trying to figure out, hey, I have that consumers, they would like to have that level of reliability. I know a different set of states of the world where I have to satisfy that reliability, and renewables contribute differently to that reliability in the states of the world. If I take a south-facing solar panel or a west-facing solar panel, they provide me a quite well-known, still uncertain, but well-known basic structure of generation. And so such a element should actually allow to transfer the preferences the consumer has for reliability into investment signals on the generation side. That's a little bit the idea. And then we can extend that even further if you go with, okay, look, there's likely, if you think about where we can install a lot of renewables, way more locational constraints than there have been before. If you build a coal station, okay, you need somewhere a place for a coal-fired power plant, but that's about it. If you build PV, you may need a lot of roofs, you need a field or whatever, where you may not even have access to because there's some owner sitting there who doesn't give a damn about electricity and doesn't want to have any risk going on. But that scheme we are thinking about could maybe allow to transfer some of that risk. So talking about risk-loving, risk-neutral, and risk-aware actors, you could think about that this allows the utility to go and say, look, I know what the profile on your roof is if I install PV, which helps my reliability structure, and I give you a fixed contract for that. So that guy wouldn't be required to go on any market with hourly structures. I just say, like with a capacity market system, I give you a fixed payment. If you install that one, you give me the energy for that. That's a little bit also the idea we have in mind, that this utility allows a little bit better this risk transfer between the different actors. It's all a little bit sketchy, totally agree on that. We are not yet there where we want to be, but that's a little bit the testing here. If you now say, hey, that's a really stupid idea, the sunk cost we invested so far for getting up with that is not that high, and we can scrap it. But if you say, actually, yeah, that makes sense, but think about this and that, that's more or less defining the roadmap we're going. And a little general problem, and the debate I had with Frank Krysiak, which is the main idea giver in here, in the back, is if you end up with such a market structure, and maybe I jump back to the very beginning, you will need somebody that ensures that whatever utility offers as a contract fulfills a specific level of reliability, because reliability by definition is uncertain. So I'm not going in historically and say, look, last year you had a 100% reliability because for some reason it all worked out. Next year you have 50% reliability because in state 1 minus alpha, we blacked you out all the time. But on average you still have 95% reliability. That's not working nicely. So somebody will have to ensure that whatever the portfolio, the contract is that the utility offers, actually matches whatever reliability level the consumer wants. And that's where I'm debating quite heavily with Frank whether that's an advantage or a disadvantage of the system, because it's a kind of different approach. We have a lot of experience with rating agencies and other market systems, so that would go in the same way. There's a contract offered by a utility, you need a rating what the reliability is in there, because in the end, the real reliability is still uncertain behind. You just need to repeat it 100 years at a time, and then you're going to end up with that average reliability. But if you're going to get bad 10 first years, consumers may not like that. So, as you see, a lot of open points. So, I hope we still have like 15 minutes for a lot of open remarks and questions, and thanks for your attention.
Okay. Monsieur Nemesis.
Okay. Thank you, Bert. So, thanks, Hannes. So, I warned Hannes beforehand that I did not understand everything from the slides. And Hannes said, yeah, things will become clearer during the presentation, but I had the feeling I had sort of a different interpretation maybe, so
that's
I'm
okay.
not sure what I'm going to tell is going to be helpful. So yeah, so I think what you do in the paper or in the presentation is going to be about reliability and how we can introduce consumers in this market and make sure that the willingness to pay for reliability from consumers is reflected into the complete value chain in the market. And I think, I mean, I put up 3 points which I think are important for that, and I guess that's also some of the things that you do. So, okay, before that, I think that what you're trying to say is that maybe one way of doing reliability is to assume that consumers have some vertical portfolio where they have some conventional energy or some wind energy, and then some consumers say, I want to have wind and I want to be exposed to the risk of wind, and some other person say, no, I want to have complete gas powered and I want to be safe. Yeah, so I think that's sort of behind you, the models that you mentioned, that somehow...
It's still technology neutral in the sense from a consumer perspective. We didn't go up with saying you have a specific preference for technologies. We just say you have a preference for availability, so to say, of your energy.
Okay, so I think then there are my 3 points. So I think that... so one question is about how you going to set up risk sharing. So you want to have instruments that are going to allocate risk optimally between the different actors in the value chain. So, and you might need to define certain products that are going to be good for sharing the risk. And what are the right instruments to hedge, let's say, a windless week And is this matched with the type of contract that you actually are offering to the downstream consumers?
Mm.
Yeah, so do you really have the optimal allocation of risk in the long run in your scheme?
Mm.
Or do you still sort of, because implicitly by setting up this contract you're still allocating some risk to consumers?
Yeah.
Is the risk allocated in an efficient way? And then the second thing is, let's say in the short run you want to make sure that consumers are shut down in an efficient way. And this means that maybe, you give up on having real-time prices, or you give up that maybe Per, okay, he's not his fridge, but he's just running a new, but putting up this PowerPoint, he doesn't want electricity to fall out. So does your model actually guarantee that you have optimal short-run timing of reliability or shutting down of capacity? And the third point, but that's something that you mentioned, if you're going to have different retailers selling different reliability contracts, I mean, how are you going to sort of monitor this quality? I mean, now everybody buys retail electricity, they assume they all obtain the same quality, the same type of product, and the system operator is not yet able in shutting down individual households. So this might change if you have smart meters. But how is then the retailer actually going to be, the consumer going to be sure that it actually has high reliability? Because it's about rolling blackout, so the event is a low probability event, and then they might say, yeah, it's a force majeure, it was not me, it was the contractor in your street who was cutting the cables, and it's not me who shut down your electricity. So I think that's not an easy problem to solve. And
No, that's one of the main clashes I have basically with Frank on that, whether that's really an improvement in the end if we end up with somebody being responsible for making a evaluation of the reliability externally. And on your second point, I totally agree that so far we don't have any short-term optimization regarding blackouts, because, and I think we're not going for that because we say, okay, we're not going into this short-term optimization because then we would end up with real-time structures anyway, which is our first best. We take that inefficiency and we want to know how far away are we in the end from the first best, and is this still okay? That's a little bit the idea. So we're going to give up some efficiency by definition. But maybe there's a way to still tweak the incentive structures, but well, given the simple time structure we have now, basically 2 states of the world, we're still too far away from getting that one. And we have no heterogeneous consumers in the beginning now. That's also some element we're going to need.
Okay.
Thanks.
Thanks very much. So, we have time for additional questions for Hannes? Discussion? Yeah. All right.
It's more a comment, but your scheme is quite similar to some things that are being used in microgrids in developing countries, where consumers can specify a maximum power level they can draw and the hours during which they want to have that power. And then there's a microgrid operator who chooses a mix of technologies that can satisfy all the individual consumer contracts. So that might be one place to look at how all these legal things have been solved. I can give you some information if you want.
That would be really helpful, yeah.
Yeah. Dick?
Could you go back to the slide that has the red triangle? I think it's a supply curve.
So I have this one,
Towards the end. Now keep going.
this one.
Yeah. Why does the red line go down?
It should just indicate that capacity ends here.
Shouldn't it go up?
Yeah. Cost-wise, yes. I just wanted to say, okay, this is the capacity block. So it's not the cost function. I'm just saying, this is my capacity range. This is my increasing cost function, and then it drifts into infinity. But I didn't want it to have another line going up in there.
It drifts to infinity, but it has a price when you draw it.
Yeah, it has.
So why don't you just charge that price?
Because then we're back to real-time pricing.
Oh, you don't like real-time price?
That's the whole point we go in there, that we say that if we have real-time pricing, all the stuff we're talking about is boring.
Oh, okay. Well, that was my next question. Why do you get rid of the first best? And it's because you don't have real-time pricing.
That's the idea, that we don't end up with a complete real-time pricing for all consumers. That's our assumption. If you don't agree with that, then naturally all that follows doesn't make
I think
sense.
that's the answer.
Well,
And it's not, I mean, we have it today, except we've implemented it incorrectly. We have the triangle going down instead of the curve going up.
yeah, and if we all agree that real-time pricing will happen, and we have enough flexibility,
It
then
is
a lot of
happening.
our debates are kind of boring.
The mechanics are all working. I mean, we have the mechanics. We do things like put a price cap on the market or something like that, which doesn't allow it to clear all the time, but we have it. In the United States, we have a real-time market.
Not a real-time market. Do you have real-time pricing for consumers? I'm not talking about the
I said we have
wholesale.
the mechanics in place. I didn't say we had it all right. And you're right. You basically need the demand side in the market. And what makes you believe that you can't get enough of the demand side in the market?
Well, that's a lot of debates internally we had whether or not that's doable in there. Frank, he's again on that point and saying, okay, he doesn't see it coming because he assumes that we as consumers, if you take, for example, telecommunication, we are more kind to having relatively fixed, predictable structures. And just because we're technically able to do that, or with whatever applications could manage that, we would still have a preference for a fixed structure. And if enough consumers go in that way, then you're losing this real-time signal. And the question is, okay, is there something that gets you pretty close to that, but is not real-time, that you can actually offer? If you have a fraction of consumers going real-time, they ain't the problem. The problem is if you have a significant fraction that does not want to go real-time for whatever reason ever, or that perceives the costs of switching to real-time too high, whether it's transaction costs or technical costs or whatever. And you could assume that maybe the utility is then kind of the in-between guy saying, okay, you'll get some more fixed structures with your contract, I'm taking part of that management, but you basically go in with some reliability constraint. You either want to have full reliability, that's costly, or you have some type of not full reliability with still fixed contract structures, but somebody basically has to manage to shut elements off in your system.
Or actually consume more.
Going in the other way, yeah, didn't Ford...
What would you say is the cheapest form of storage?
The cheapest form of storage is basically shifting my demand to when it's available in supply side.
Exactly. The thermal capacity of these buildings is a storage device. How much do you have to pay to implement this?
We have a project on that actually, trying to figure out what's the heating structure linked to the electricity system, because heating gives you a lot of flexibility in the electricity system.
And that's something that you can implement just with real-time pricing and a look-ahead model.
Not sure you need real-time pricing for that.
No, I don't know. How would you price battery storage?
Well, the question is always who is the actor within the game and what's his game. So if you have a battery, basically he needs to have a good pricing signal, otherwise he's not operating properly. And then following that logic, anything that's demand side management is kind of a virtual battery, so they should have the same signal. Question is, can I force somebody installing a battery that, hey, you installed a battery, now you need that contract structure, which is close to real time, to somebody saying, hey, I don't give a damn about your stupid electricity. Give me electricity out of the socket. I pay you a price for that. I don't want to be hassled with anything real time. It's just an assumption. It's just an assumption.
You can get that contract without having a government intervention. They have those in ERCOT. You get free electricity on weekends and evenings.
Like a cell phone. So in California, the board of governors, the California ISO, swoons before Elon Musk and carves out, if you're a residential customer and you put a power wall, they'll put a meter on it and give you a wholesale price to incent that storage. But of course that's 10, 100 times as expensive as pre-cooling your house and that sort of stuff. But you don't have a carve out for that. So we're helping Elon Musk, which I suppose we'll get all sorts of learning benefits from that, right, David?
Yeah.
We don't get learning. But I think there's a lot to be learned about thermal storage and taking advantage of that. I had the next question here.
So, kind of follow-up question. So, your reliability is just of percentage, but I mean, realistically, consumers, they care about duration, right? So,
Yeah,
I'm
yeah,
okay if
yeah.
if I have temperature control, I want to, have a band on my temperature. I'm not willing to shut down for a day. So, is there any way how you incorporate this into market design?
It's definitely on the to-do list for the long run, because what we have now is basically just no real evaluation in regarding that, but it strongly depends on the utility side you assume for households, that reliability has both a quantity and a time component. So being interrupted for like 5 minutes on a normal day likely doesn't care. Being interrupted for a couple of hours, that's a problem. Being interrupted completely is different to being interrupted like I'd only have 10% of the promised capacity not available. So it has both elements. For now we just assume there is some utility function behind and we keep it as simple. But the more we understand what's going on in such schemes, we naturally need to extend on that dimensions. And there's likely going to be also cutoff points where you say, okay, maybe this is nothing that the pure contract structure can guarantee. Maybe there's then still a need for something on the more governmental side.
Eric was next.
Yeah, something that I didn't ask yet before. So I wanted to ask you, what's the role of the government that you believe? Because if retailers pay the real-time prices, and we have introduced smart meters where we maybe observe real-time consumption, what are the externalities that arise between the contract, between the retailer and between the household? Do we need to intervene, or will the retailer actually offer the contract which is socially optimal because it takes into account what consumers want and it takes into account real-time prices? Or are there certain externalities that you want to regulate as a government? What are those externalities, and what would this mean for the type of contracts you would allow them?
So far, we didn't thought about that yet in that regard. So the idea is still basically that there's no governmental intervention needed in the first place. It's basically just translating whatever consumer want to the utility side. We didn't check whether, if you assume some more market power structures, that ends up in a nice solution. It could easily be that you may have to intervene from a governmental side for market power reasons, but we didn't check on that at all. And the only role we have so far is that somebody needs to check this contract, which doesn't need to be the government. So right now, government is basically out of that role. But I agree. Again, once we have a better understanding what the interactions are and what the motivations behind are, we need to check whether there are externalities of that structure that need to be addressed. But so far, we didn't check on that.
Anybody like the honor of the last question of the first day? Knowing you're standing between us and okay, terrific discussion. Thank you, Hannes.